Welcome to Waseda University. I'm Patrick DeJarnette, an associate professor here at Waseda University, and I'll be giving you a short lecture on behavioral economics today, about 30 minutes or so. Okay, and before we get into exactly what behavioral economics is, let me just ask you the following question. If you heard the following request, someone stopped you on the street and just said, hey, please put your hands up in the air, stick your tongue out, jump up and down, would you do it? I mean, would you do it without asking, right? Without even wondering why, right? Probably the first thing we encounter, or first response we have when we encounter something ridiculous is something like, well, why do I need to do this, right? Now, with State University, we have a lot of great faculty, but I think you should still come in with this why mindset, right? Why do I need to study this? Or why do you think this is true, right? In other words, assume everything you encounter at Waseda University is ridiculous. That'd be my advice. Okay, and think of yourself as like kind of a detective, and you need to find the truth. And there's a lot of different information you're going to receive. Some of it might be true, some of it might not be. And what you're going to do is try and figure out which elements are true and not. Okay, and I'm not saying that you're going to encounter a lot of false information at Waseda University, but rather that by employing that mindset, I think you'll find that you learn more. That's my personal opinion. Okay. And so the favorite question that I would recommend is, why is this wrong? Assume it's wrong and then try to figure out what it is that's wrong about it. Okay. And, if you can't find anything wrong with it, if you assume it's wrong, you try to think about why it's wrong and you can't find any reason it's wrong, well, then maybe it's right. Okay. So when it comes to behavioral economics, it's kind of a way to challenge the assumptions of traditional economics, okay, at least historically. And what's the fastest way to challenge something? Well, as we just discussed, when you ask why, right? So there are some things you're going to learn throughout your time at Waseda University, especially in the economics courses. Things like people have consistent preferences. People maximize utility, which you may have never heard of before, but you'll encounter before long. People like more to less. People are not satiated, meaning people are not perfectly satisfied with what they have, I guess you could say. And raising prices decrease demand. Okay, so some of these facts are actually pretty well founded in empirical evidence. Okay, and so if you kind of dig into it, you'll probably find that you believe them as well. But without asking why, how are we going to know which ones are kind of well founded and which ones aren't? All right, and that's kind of what behavioral economics is going about. It's going to say, okay, let's look at each of these and really try and figure out which of these are, always true, which are sometimes true, and which may not be true that often. Okay, so yeah, some questions you can think about while you're taking even this class, of course, or this lecture. Why do we have a model of utility, or how does this help? Why does my professor think it's true? I mean, you could apply that question to basically all of your courses at Waseda University. Why do I need to know this? Which is a perfectly valid question, right? And I hope that you do ask that from time to time to get a sense of what you're trying to achieve by learning this material. And then, in this case, like, why do people buy less when the price increases? Like, even if we do find that to be true empirically, why is it true? Okay. And so ask yourself, why? And once you get into that mindset of asking why, I think you're going to find that it's really valuable even outside of Waseda University, right? After you leave, that you'll think about, well, why do I think this is true? You'll challenge your own assumptions. Why will my competitors fail, or why will my idea succeed? And why not try something new? So by asking yourself these kinds of why questions, I think you'll get into a pretty good habit of digging out the truth. Okay. So rather than talk more about the classes, I want to get into behavioral economics. So when it comes to behavioral economics, I kind of think it as a refocusing on how people actually do choose rather than how they should choose, right? There were a long history of economic theory that kind of became codified over time and gave some really nice predictions. But not all of those predictions are always true. Now, that being said, a lot of times they make good models and they do make strong predictions, but it's still worth exploring alternatives in my mind. Okay, so I think that overall, this is really about kind of rethinking about how people are going to make decisions. Okay, and we're going to give you some examples in just a second. So just a little bit about me. So I'm Patrick DeJarnette, as I mentioned. I'm associate professor here, and here's my email in case you have any questions about today's 30-minute lecture. As a bit of background, I did my undergraduate degree at the University of Chicago. I got my PhD at the Wharton School at the University of Pennsylvania. I spent 3 years teaching at National Taiwan University, and I've now started teaching at Waseda University since 2019. Okay, so that's just a little bit about my personal background so you can get a sense of it. I'm not that far out from my PhD program, so I kind of still remember what it is, what it's like to be a student. So feel free to shoot me any questions if you have, and I'll try my best to answer them. So we're not going to have time for all 7 of these today. This would be more like an hour and a half lecture, at best. Sometimes I'd run over probably, but with only 30 minutes, I'm hoping we can get through maybe the first 2, maybe the first 3. We'll see, okay? And I'll try to give you some examples that are both illustrative and also real-world examples. So the first topic I want to talk about is temporal inconsistency, okay? And when you hear these words, temporal, it has something to do with time, and inconsistency, if you kind of looked it up in a thesaurus or something, it'd be unstable or erratic, right? Something changing over time, right? So that's kind of what it means. So you might walk away from this being like, oh, okay, so it's some kind of like time travel or something like that. No, obviously not, right? So what we mean by temporal inconsistency is that your preferences are inconsistent over time. Okay, in other words, the choices you make today and the choices you make tomorrow, or the choices you make for tomorrow, could all be very different. Okay, and in some cases, that can just be a simple misprediction, right? So just to give you an example, one time my wife and I, we were going to go to, I think it was San Juan in Puerto Rico to celebrate, I think, an anniversary. So we were hoping to go and spend some time on the beach under like a nice palm tree, right? And what actually happened was we landed right before a hurricane, right? So basically we had to stay inside for most of the trip. Thankfully, we're safe, nothing wrong, on our end. But overall, I would say that, that was not really an example of temporal inconsistency, right? It was just more of a simple misprediction, right? We didn't anticipate the storm would hit, especially when we were ordering the tickets. And then we also, maybe didn't pay enough attention to the weather news, that kind of thing. So that's something that just, sometimes bad events happens, or sometimes things are out of our control, okay? And that's not really what we mean by temporal inconsistency, okay? Other times when we make predictions, we find ourselves consistently wrong, or consistently, you could say consistently inconsistent, right? That you're frequently wrong, right? So in other words, if I walked outside assuming that every day would be sunny, and I wear outfits that are, I never buy a jacket because I think, well, it's never going to rain again, that might be something along the lines of temporal inconsistency, okay? Something that's consistently wrong. So I'll give you some example of some plans, and these are from David Lapson, I should give credit. These are some plans that you don't hear very often. So I plan to watch more TV next year. I plan to eat more cookies next year. I plan to miss more classes next year, or I plan to smoke cigarettes next year. I plan to exercise less next year, and so on. So these are plans that you don't hear very often. Another way to put it is that, like, obviously we tend to hear people saying things like, oh, I really want to start exercising more, or I really want to start sleeping more, right? So these are kinds of, the fact that we consistently think, oh, in the future I'll exercise more, right? That's a bit puzzling, right? Why is it always in that direction of like, well, I'm not exercising enough now, I'll exercise more in the future. I'm definitely going to do it in the future, right? So let's explore this a little bit more detailed. So here's a kind of simple example. Which would you most prefer? A 15-minute massage now, or a 20-minute massage in 1 hour from now? You can just think about it to yourself. So, it's a 15-minute back massage or a 20-minute back massage in 1 hour. So you have to wait an hour before you get the massage, but then you get 5 extra minutes. Okay? And now I'm going to change the timing. So which would you prefer now? 15-minute massage in 168 hours, or a 20-minute massage in 169 hours? So 168 hours is, I think, 7 days. Yeah, exactly 7 days. So it's basically 1 week away, right? Um, the only thing we've changed, we didn't change the number of minutes of the massage, we just changed how far out is it. Okay, so in this case, you can get a 15-minute massage immediately, right? Or if you want to wait an hour, you get 5 extra minutes. That seems like maybe when you first heard this question, it might seem like a long time to wait for an extra 5 minutes massage. Some of you might be very patient and say, okay, I don't mind waiting an hour for a massage. Some of you might not want a massage at all. I'm actually in that category myself. I'm not really a fan of massages. But anyways, the the key thing is that at least when I ask this question to large groups of people, there's a fair amount of people who will want the 15-minute massage now, but when we switch it to a week from now versus a week plus 1 hour, most will prefer the 20-minute massage. Okay, that waiting an extra hour when it's a week away doesn't seem as bad as waiting an hour now. Okay, and that's kind of an example of temporal inconsistency as modeled by traditional economic models. Okay, and I'll show you very briefly how we might model this decision-making process. So here we have a number of massage minutes at time 1 would be M1 at the top. Number of massage minutes at time 2 would be M2. So this would be like 1 hour and now. So M1 would be number of massage minutes maybe now, and M2 would be number of massage minutes at time 2, which would be 1 hour from now. Okay, and then we could even come up with a mathematical model that would describe your total utility, or for now you can probably think of it as total happiness for massages at time 1 and time 2. So we have U of M1 and M2 equals little u of M1, basically how many minutes of massage you get now, plus delta, which is a number, okay, that we don't know right now. I'll go into more detail in a second. Delta times u of M2. So it's the same little u function, right? And we have M1, M2 representing massage minutes now and massage minutes an hour from now, respectively. Okay, so if, let's start with the easy case. If delta was equal to 0, what would this equation imply? So we have this u M1, M2 function, right? If delta was equal to 0, then we'd basically say big U of M1, M2 is little u M1 plus 0 times u of M2. Well, 0 times anything is 0. So it would just be little u of M1, right? And what does that mean about your happiness for massage an hour from now? Remember, M2 is the amount of minutes of massage that you're going to get an hour from now. And how does it enter into your happiness function, if you want to think of it that way? Well, if delta is equal to 0, basically it's saying that M2 doesn't enter into my utility. It doesn't enter into my happiness, right? M2 could be like, 60 minutes of massage, and it doesn't make me any happier, right? Because delta is 0. It just doesn't enter into my happiness function, right? So delta equals 0 basically says that I don't value the future, or in this example, I don't value massage in the future. If delta is equal to 1, what would the equation imply? In that case, we have u of M1 plus little u of M2, right? The delta would just be 1, so we could just kind of omit it, right? So u of M1 plus u of M2, that would be my happiness function, right? And what does that mean about my my value of minutes of massage now versus my value of massage minutes an hour from now? Well, it basically says that they're kind of symmetric, right? It's kind of like you value them equally, or at least you regard them equally, right? Because at that point we just have little u of M1 and little u M2, right? And it's kind of interchangeable, right? It's almost like an hour from now or now, it kind of doesn't matter to you, okay? Now, some of that depends upon the curvature of that u function, the little u function, but at least it's symmetric in a sense, okay? So that, the future seems, like broadly speaking, the future is as valuable as now, okay? So what I'm trying to get across here is that delta is going to capture the weight we place on the future, how important we think the future is, right? So usually in these models, we assume and find evidence for delta less than 1. You could, in theory, imagine delta greater than 1 as well, right? If we go back a slide. If delta is greater than 1, what might that imply? it might be easier if you actually plug in like a u function. Maybe you think about u of m1 is like the square root of m1 or something like that might help. But in general, if delta is greater than 1, it seems to imply that the future is more valuable than now, right? So you could imagine that. And in fact, it's not totally unreasonable to think about some cases where that might be true, right? In the sense of like, well, you might think about it in terms of like, oh, I'm studying and I'm studying to earn income in the future, so I do value the future. And that's something that, could be captured with a delta greater than 1, although typically we wouldn't model it that way. But, there are some reasons or some examples you might think of where you might feel like you value the future more than you value now, okay? So, but historically, we find very strong evidence that delta is less than 1, okay? If we had a third time period, for example, like let's say a massage now, a massage an hour from now, and a massage 2 hours from now, okay, we would typically model this with another delta, but in this case, the delta now becomes squared. So it's u of m1 plus delta times u of m2 plus delta squared u of m3, all right? And here, although I was talking about hours of massage, this time period could be days, months, weeks, it's just a different delta. But basically, we're going to use the same model, the same basic model, which we call the exponential model, to analyze decisions over time. Okay, and let's now take this model, which is pretty widespread, and reevaluate our decisions from the massage example with this model. Okay, so I asked you in the beginning, which would you prefer? A 15-minute massage now, right, which would be m1 is equal to 15 and m2 is equal to 0. So that would just boil down to little u of 15. And a 20-minute massage in an hour, which would be u of 0 and 20. So basically we have no minutes of massage now, but we get 20 minutes in 1 hour in the second time period, right? So we have u of 0 plus delta u of 20. And, assuming that 0 minutes of massage gives you no happiness, then we just kind of drop that part out and we're left with delta times u of 20, okay? So in this question, if you chose now, right, in other words, if you said, I want the 15-minute massage now, then that basically means that the utility of 15 is bigger than delta times the utility of 20, which is perfectly fine. There's nothing wrong or invalid or anything wrong with that, right? You might just prefer 15 minutes massage now more than 20-minute massages an hour. That's okay. But what I'm going to show you is that if we switch our preferences, which, at least when I've done this in the past in the classroom, many people do, if you switch your preferences, that the model that we've described no longer captures your preferences, okay? And what I'm going to show you what I mean by that. So if we preferred a 20-minute massage 169 hours, that's usually the most common response I get, a 20-minute massage 169 hours, then that basically means that we have delta to the 168th power times u of 20 in the model that we've described, right? Versus a 15-minute massage 168 hours, that's delta to the 167 times u of 15, okay? So comparing these two options, if you chose a 20-minute massage in 169 hours, then it implies that the u of 15 is less than delta times u of 20 because delta to the 167 power cancels out from both sides, okay? Now, I know this might be a little confusing to you. You probably have not seen a model of utility before, so don't worry too much about the details. But what I'm trying to highlight here is that this resulted, if you chose 15-minute massage now over 20-minute massage an hour, and then you later chose 20-minute massage on 69 hours over a 15-minute massage on 68 hours, which is very common to do, most people do it actually, then the model that I've described, which you'll have to take my word for it, I guess, that it's widely used, cannot capture these preferences. Okay, it's not like you are wrong. It's not like you are irrational. It's that the model is wrong, right? The model was unable to capture your preferences if you did that switch, okay? If you chose 20-minute massage an hour and 20-minute massage on 69 hours, then that's fine. Maybe the model could work for you. We haven't violated the model for you. Or if you chose 15-minute massage now and 15-minute massage on 68 hours, then again, the model seems to work okay for you potentially. But since a lot of people do switch from 15-minute massage now to 20-minute massage in 9 hours, for at least a large category of people, it does fail to predict their choices. Okay. And it's not only this hypothetical, classroom exercise. People, I should say, economists have studied this when it comes to working out, for example, working out at the gym. Okay. So if you were given, you're thinking about going to the gym, you're given two possible contracts. One contract says, okay, you can come here for, I think it's $70 a month. As many times as you want, $70 a month. Sorry, my son's really excited to go outside. But that's one option, right? Contract one, $70 a month, come as many times as you want. Option two, there's no contract, or it's basically per visit contract, where it basically says, oh, every time you come, you pay $10. Okay. And sorry, I should be saying US dollars, right? Of course, you could convert it to yen. So like 7,000 yen. No, yeah, 7,000 yen a month versus 1,000 yen a visit, something like that. Okay. So which of these two contracts would you prefer? All right. So just to clarify, $7,000, sorry, no, 7,000 yen per month for unlimited access versus 1,000 yen per month every time you visit. Okay. If your only objective was to save money, right, which one would you choose? Well, it might depend on how often you plan to visit the gym, right? If you plan to go only 3 times a month, right, it's much cheaper to just pay every time you go. If you plan to go 10 or 15 times a month, okay, then actually it works out to subscribe and get the month per month contract and pay $7,000 a month. I keep saying 7,000 yen per month. So, it really depends on how frequently you plan to visit. Okay, and what these economists have studied is, well, they looked at people and they analyzed, okay, you subscribed, they had this option, they could pay per visit or they could pay per month. And they looked at the people who decide to come, or decide to pay per month, and they looked and said, how often do these people go, right? Now, you might expect some variation, right? For example, I might plan to go 10 times in 1 month, but then, I don't know, I twist my ankle, I can't go 3 or 4 times, and I've already subscribed, so I can't like cancel that month's subscription at least. So, there might be some people who would go like under 7 times a month, right? That's kind of the magic number where it works out, right? If you plan to go more than 7 times per month and you actually go more than 7 times per month, then it made sense to get the contract, okay, where you're paying for the unlimited visits. Okay, so, you might expect some people not to hit that magic number of 7, right? But what they found is the vast majority don't. I think the average number of visits for those people who signed the contract was about 4. Okay, in other words, they could have been saving $30 a month just paying per visit on average. Okay, and of course, there's some people who didn't go at all and we're still paying $70 a month. Now, of course, there were also some people that probably went 10 or 15 times, and for them, it was a good deal. But the vast majority were under 7. Okay, so it's possible there was some other things going on. Like maybe there was a really nice salesperson at the front who like made a nice song and dance about why you should really join the gym and how it's going to change your lifestyle, and they kind of convince you even though you didn't want to be convinced, something like that. I mentioned earlier, like assuming that your only goal is to kind of save money, that might not be a very safe assumption, right? Going back to why should that be reasonable, right? Like maybe I subscribe to the gym because I want to force myself into a contract so that I go more often. There could be other explanations for it. But what I'm trying to highlight here is that these people made a plan to go to the gym more than 7 times a month. And it seems like by and large, they failed to actually succeed at that plan. Okay. And it was very one directional, right? Not many people who were paying per month went more than 7 times. I'm sorry, paying per visit. People who paid per visit, they didn't go more than 7 times. Okay, usually. So, yeah, so actually, I'm sorry, this is all of the information I just said verbally. I forgot that I had in the slide. I apologize. But you can pause it pause the video if you want to look at the details. Okay. So we do find that, basically, just to recap, we do find that people have some temporal inconsistency, not just in these examples about massages, but also in terms of going to the gym, and it ends up costing people hundreds of dollars. Okay, hundreds of dollars per year, and actually, even several hundreds of dollars over the course of like 2 or 3 years. Okay, so that's a case where, especially exercise in particular, I think people might be temporarily inconsistent. They might make plans to go to the gym a lot, maybe 7 times a month, and then they fail to live up to those plans. Okay, and we can explain that with some other models. But let me give you another reason why we think this exponential model might not be accurate in all cases. So I'm going to give you a prompt. Suppose you value tomorrow at 99% of today. Okay, I know that's kind of a vague statement, but I guess what I'm trying to say is that tomorrow is like 99% as important to you as today, broadly speaking. Okay, so what would that mean? Okay, suppose you're also willing to pay 300 yen today for fries to be delivered today. Okay, so to clarify, you would be willing to pay, like, your friend $300 yen, and say, hey, pick me up some fries when you're on your way to the store and bring them back to me. If you're willing to do that, okay, then these two statements combined imply, under the exponential model, that you'd be willing to pay only 7.8 yen today for fries to be delivered in 1 year. Okay, now, this is, again, assuming that you trust your friend fully. Maybe it's like a magical fry fairy who's going to fly to McDonald's or Mossburger and get you some fries 1 year from now, and the fry fairy doesn't lie, doesn't cheat. Although I don't know why you trust a fry fairy, but yeah, anyway. So under this situation, you'd be willing to pay only 7.8 yen today for fries delivered in 1 year. Okay, if we go further out under this exponential model, you're only willing to pay 0.0000, there's too many zeros, 3 yen today for fries to be delivered in 10 years. Okay, now that amount of yen is so little, it's almost incomprehensible. Okay, I mean, it's literally probably less than the amount of value that your pocket lint has. I mean, like, pocket lint, in theory, if you like gathered it all up, could be like used as a fuel or something like that, or like for recycling. So it's really, really, really trivial amount of money. And to give you a better sense of the scale, let's just switch context from fries to Microsoft. Okay, so we're still under this case where we have exponential discounting, that model I discussed before, and you are valuing tomorrow at 99% of today. Okay, so let's also assume that you're willing to pay 45 trillion yen today to acquire Microsoft. Now, obviously, I don't have that in my bank account. I assume none of you do. But suppose you were willing to pay it. You had the funds. You were willing to pay that much to acquire Microsoft. Okay, and that's approximately the market value of Microsoft last I checked. So that would imply that you're willing to pay less than 3 yen today to acquire Microsoft in 10 years. Right? That's how the scale of this works. So all those zeros I was saying before, like, when you multiply this kind of thing up by 45 trillion yen, it means that if you're willing to pay 45 trillion yen today to acquire Microsoft, you're only willing to pay 3 yen to acquire it in 10 years from now, which is obviously ridiculous, right? Like, anyone who's unwilling to pay 3 yen today to acquire Microsoft, the entirety of Microsoft in 10 years, I don't know. Yeah, this is a very dangerous person. I don't know where their mind's at, right? I mean, it's only 3 yen, okay? But that's what that model implies, okay? That's what the model implies about how you're valuing the future if you value tomorrow at 99% of today. Now, I said you should always question assumptions. Is that a reasonable assumption that you value tomorrow at 99% of today? Well, I'm going to provide you some evidence about that. But let's just, before we get to the evidence, let's think about it a little bit, right? Like, on the one hand, do I value tomorrow at 99% of today? You might say, I value it at more than 99% of today, right? Because I assume I'm going to live tomorrow as well. I hope I'm not going to, knock on the wood, pass away today. So, I think tomorrow's tomorrow's almost as valuable as today, maybe more than 99%. Okay, and we'll talk about that. Or you might go the other way, right? You might say, wow, do I really value tomorrow at 99% of how much I value today? Like, just imagine, like, if you had a problem, or maybe exercise. Let's go with a problem set. Let's say you had a problem set due and it's due in a week. Does that mean like you evenly space out the problem set over the course of the week? I hope so. But some of you might end up finding yourselves waiting till like the last 2 days to finish the whole problem set, right? So, or the homework, in other words. Okay, so, you know, we could go in either direction for whether or not people value tomorrow at 99% of today. Let's try one more. I think I have some evidence here. So yeah, so for another economist, Jesse Shapiro looked at, is there a daily discount rate? So he looked at how people purchase groceries, okay, when they're on a limited budget, okay? And he found something very interesting, which is that in the beginning of the month, which is when people usually get their paycheck in the U.S. at least, or their food stamps, basically. For these people that have a kind of low income, they're going to consume 10 to 15% more calories in the beginning of the month than the end. And when you put it in monetary terms, it's even bigger. So it's in the beginning, there's 30% more money spent, okay, than in the end. So in the beginning of the month, basically, they buy high value, reasonable amounts of calories food, right? But by the end of the month, when the budgets basically run out, when they don't have much money left, they start buying low value and high calorie foods. Okay, and even though they're trying to buy high calorie foods, they don't get the same amount of calories that they got in the beginning. And then at the beginning of the next month, they start the process over again. So it's basically like a cyclical pattern. Like, oh, at the beginning of every month, you eat a lot of calories and spend a lot of money. And then toward the end of the month, you start to run out and you wait and then you start up again and do it again. So with this empirical pattern, Dr. Shapiro basically tried to figure out what is the delta, right? What delta do these people exhibit, okay, based on calories? And so he found that people value, I think, at 99.6% of today. Tomorrow is valued at 99.6% of today based on this evidence, okay? And when you take that to an exponential model, right, it's a very, very high rate, okay? It basically implies that you would agree to 39,000 yen today in exchange for losing 30,000 yen a year for the rest of your life, okay? Basically, even though it's a high number, a relatively high number, it still results in something kind of silly, right? Like most people would not be willing, I think, in actual practice to say, okay, give me 39,000 yen today and I'll give you 30,000 yen a year for the rest of my life, right? Except for that first year, right? So in other words, this is already a really bad deal by the second year, right? You've already lost a bunch of money by the second year. And if you keep going on, like every year, you're going to lose an extra 30,000 yen, okay? So yeah, this is already placing a lot of value on today, okay? And if we take that to the Microsoft example, it basically says that you're willing to pay 7.5 yen today to acquire Microsoft in 20 years, right? So I switched from 10 years to 20 years, but it's still pretty ridiculous, right? I mean, 20 years is a long time. It's a substantial chunk of anyone's life. But still, 7.5 yen is so little, right? To acquire a company that's worth, billions, trillions, or trillions of yen at least, that seems like a bad decision, if they said, oh, it's 10 yen to buy Microsoft in 20 years, you're like, oh, that's too rich for my blood. That's scary to me. Okay, so the takeaway from temporal inconsistency is we do have some evidence from multiple domains. We talked about gym exercise. We also talked about buying food. That people behave in a pattern that's not really well represented by an exponential discounting model, which is, broadly speaking, one of the more widely used models in at least analyzing economic decision making over time. Okay, but that's why behavioral economics has come along and highlighted that issue, and there are now some new models that do capture those behavioral patterns a little bit better. Okay, and so in a full behavioral economics course, you'd probably learn those models as well as go into more details about the examples I discussed. But yeah, unfortunately, we don't have time for that today. Actually, let me check what time we do have. Oh, wow. Okay, so we're already 35 minutes in. Okay. Sorry. Yeah, that happens to me sometimes. Okay, so the endowment effect is fun, but I think I want to talk about probability weighting. Yeah, and I'll do 5 minutes like speed run. Okay. So we'll go back to our massage example, okay? And before we were talking about like massage now versus later, but some of you might not like massages, like myself, and you might be thinking about why you don't like massages, and maybe you're worried about assassins, right? If you imagine the chance that there's like a 0.001% chance that the masseuse is actually an assassin, you've watched too many James Bond films or something, or maybe it's not really an assassin. Maybe it's just they accidentally push too hard and they break your neck or something like that. Okay, I mean that's not really why I'm afraid of them, or not afraid. I just don't like them actually. But anyway, yeah. So which would you prefer? Let's focus on you. So 0.001% chance of death or a 99.999 chance of massage, right? A normal massage, okay? Or you have a sore neck. It's like these are your two options. Like for today, like those are your two options. Which would you prefer the most? Okay. Well, even though this is a very silly example, historically, it was something kind of similar to what people faced. And the real world example is actually shaving, right? So shaving nowadays is pretty risk-free, but that's only because of modern inventions, I would say. Okay, and I'll discuss that, relatively modern. Hundreds of years ago, it was a real risk. And you had to make a decision about like, oh, am I going to get shaven, or shorn, I guess you could say, or am I going to have a beard, right? It's kind of like on the same scale because there's a chance in the past when you're shaving that you end up, well, one situation could be that you end up with something like Sweeney Todd, okay, which is a kind of famous musical. Well, I guess it's a play. Was it always a musical? Was it ever a book? I don't think it was a book. I think it was a play, and they turned it into a musical. But anyway, if you enjoy musicals, check out the Tim Burton version. Yeah, I also have another recommendation for a musical if you're interested. But we're gonna move ahead. So I mean, you might end up with a barber who wants to kill people. That's kind of, sorry to spoil Sweeney Todd, but I mean, it happens in the first 10 or 15 minutes. I think it's not that surprising. But no, the real risk was actually infection by the razors. Okay, so you guys might be familiar with Henry David Thoreau. If you aren't, I would recommend checking out some of his books. I think they're pretty interesting. His brother actually died by an infection from a razor. Okay, so that actually led Henry David Thoreau to seclude himself from society, at Walden Pond, and led to his probably most famous book, Walden. Okay, so I really recommend checking out the book Walden if you have a chance. But that was actually a real event that happened to him, right? And I don't know, maybe that's why he has so much hair around his neck and none on his face. Like he doesn't want the barber to go near his neck. I don't know. Maybe it was just a style. I don't mean to make fun of his appearance. He was actually really humble. He was like, well, at least about his appearance. Anyway, let's move on. So the safety razor came about in 1901, okay, and that's basically what solved some of these issues. Okay, it doesn't really solve really the infection problem. You start to clean the razors, but at least you're not going to nick yourself so deep that you cut your arteries. Okay, it's designed at least to prevent that. Okay, and of course the modern disposable razors we have are kind of an offshoot of these safety razors. Okay, although I recommend if you do shave to check out the traditional safety razors. They're far cheaper. They work better. It takes a little bit of learning how to do it, but anyways, it'll save you money in the long run too. Okay, so right, yeah, we're back to economics. Right, there was a little bit of interlude. Okay, but what I'm trying to say is these are relatively low probability events, right? Like the death of a razor blade killing, or sorry, even though I said it came about for Henry David Thoreau's brother, it was still a pretty rare event, right? And the question is, how do we handle these very, very low probability events, right? And what I'm going to do is introduce an alternative to expected utility if we have time, or at least try to discuss why this traditional model that we use called expected utility may not capture all of our preferences, okay? And the basic intuition here is that humans aren't great at math. So 0.1% and 0.001%, they feel kind of similar, right? Even if you look at those numbers, like, yeah, 0.1% is bigger than 0.001%, but, they kind of seem about the same, right? I don't know. It doesn't seem that different, but they're really 2 orders of magnitude different. It's 100 times more likely to encounter a 0.1% event than a 0.001% event. Okay. Yeah, so that's actually pretty substantial. Okay, but we don't feel like it's that substantial. Okay, and I say recall expected utility. I'm sorry, that's a typo. I should say here's a preview of expected utility. Okay, and you're going to encounter this probably in microeconomics 2, I think. Maybe in introductory principles of microeconomics or something like that as well. Well, yeah, but you'll encounter this, I think, probably by your sophomore year for sure, I would say. Okay, it's a pretty widely used model of how people handle how people handle decisions under risk. Okay, and there's a lot of theoretical underpinnings for this, a very elegant, beautiful theoretical underpinning for it, really. But the assumptions that underlie that theory can always be wrong, right? That's kind of the theme of today's introductory video. Okay, so for the following choice, consider, please, lotteries 1A and 1B, and I will end soon. Let me double check the time. Yeah, I do need to end soon. Lotteries 1A and 1B. So lottery 1A is 100% chance of winning $100, or 1B, 50% chance of winning $200. Okay, so I've cut the probability in half, but I've doubled the prize. Okay, if we wanted to use yen, I guess like 10,000 yen and 20,000 yen. Yeah, 20,000 yen is about equivalent. Okay, so think to yourself, which would you prefer, 1A or 1B? You only get one of the two, okay? And you have to choose, do I want a 100% chance of winning 100, so I get $100 for sure, basically, or a 50% chance of winning 200? Okay, so mentally commit yourself. If you have to, pause the video. Commit yourself to one of these two. Okay. Most chose 1A. Okay, if you chose 1B, that's fine. Nothing wrong with that. Perfectly valid. Nothing irrational. Nothing, nothing to be ashamed about. Okay, just the majority chose 1A. That's fine. Okay, either way is okay. Lotteries 2A and 2B. Okay, we have now here 2A is a 2% chance of winning $100, or 2B, a 1% chance of winning $200. Okay, so again, the prizes are the same. In fact, they're monetarily exactly the same, right? 100 and 200, those are the same. Okay, the only thing that changed is the probabilities. I went from 100% in 1A to 2% in 2A, and 50% in 1B to 1% in 2B. So now think to yourself, which of these two would you prefer? Maybe pause the video if you'd like. Okay, and most, about 60%, now choose 2B. Okay, but note here something interesting. We tend to think of ourselves as risk averse, right? Especially when it comes to 1A and 1B. Most people act in a risk averse manner. And if you haven't heard that term, that's okay. But basically, we tend to think people don't like risk, right? But for lotteries 2A and 2B, we're now finding that the majority actually chose the risk-loving option. In other words, the riskier option. They wanted to have a lower chance of winning in exchange for a higher prize. Okay, and I don't know about you, but at least if I was deciding along these lines, I might think when it comes to lotteries 1A and 1B, something like, oh, I really don't want to lose, any money, so I'll just choose the safe thing. When it came to 2A and 2B, right, it's like, well, 2% chance and a 1% chance, they're like the same thing. It's almost no difference. So I'll choose the riskier amount, or the bigger amount. So basically, even though these are, again, 2A is twice as likely as 2B, 1A is twice as likely as 1A is twice as likely as 1B, even though the ratio of the probabilities is the same, right? Because the magnitudes are different, we seem to switch our preferences. Now I'm okay with risk because I feel like 1% and 2% aren't that different, but they are different. One's twice as likely as the other. Okay. And we have some slides here, which we will not have time for, to prove that this doesn't work under expected utility, but that's okay because, well, you can pause the video now if you'd like, and you'll kind of see the contradiction. But honestly, you're going to encounter this model later. So if you don't understand this now, don't worry about it. That'd be my advice. Anyway, so yeah, what the takeaway from this example was the expect utility cannot explain the preferences for lottery 1A and 2B. In other words, even though the majority of people do switch in that direction, and even though this is the most common model for decision making under uncertainty, it doesn't seem to satisfy the prediction, or rather, the model cannot predict that change from 1A to 2B. Okay, so there is an alternative that we've come up with where we weight the probabilities. Okay, and how do we seem to find people weighting probabilities? Well, at least based on current evidence, it seems like people overweight small probabilities and underweight large probabilities. In other words, a probability of 1/3, I treat it as about 1/3. But for probabilities less than 1/3, okay, for example, a 1% probability or 2% probability, I tend to overweight them. I think of 1% as like 5%, and I think of 2% as like maybe 7%. Did that work out? Yeah, 1%. I think of 1% as like 5%. I think of 2% as like 7%. Okay, something like that. There's still a difference, right? I still recognize that 1% is less than 2%, but I don't feel like the difference is very large, right? And so as a result, these small probability events get more weight, okay? And that's what kind of encouraged me to choose the really risky option when I had very small probabilities, okay? Even though I talked about this from a way, motivation as like making you more risky, it can also lead you to be very, very, very risk averse. So you might, for example, have encountered warranties on durable goods like cameras, right? At least back in the US, especially when I was a teenager or something like that, every time you buy a piece of hardware, you go to the front, you check out, and they say, oh, do you want to buy the warranty? These warranties are basically additional insurance in a sense against accidents or events that damage the machinery, okay? And it turns out that these are some of the most profitable revenue streams for these companies. In fact, they don't make that much money from the camera itself. They make more money from the like insurance of the camera, okay? At least in the US and historically. I'm not sure if that's still true anymore, but at least historically, okay? So I have some notes about an example here from a research paper, but basically people were buying like a $150 camera and buying 2 years of extra warranty for about $18. It's over 10% of the price of the camera for a probability of it breaking being very, very, very low. Okay, so I'm sorry we don't have more time to go into this, but it basically turns out that you're acting, or not you, I'm sorry, the people who are buying these insurances were acting very, 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 very risk averse. So risk averse that it's unreasonable, okay? And so that would be another kind of indirect piece of evidence for something like you're overweighting the small probabilities. In your mind, even though it's a relatively small probability of the camera breaking, you feel like it's almost like 30% chance of it breaking, something like that, okay? So, yeah, it's not only for camcorders or for digital cameras. It's also true for VCRs, which was a technology where you kind of like a DVD player, but it's like a tape. I don't think it's used anymore, of course, but yeah, it basically, I think it was like a prototype for the DVD player, okay, or Blu-ray player. Maybe you don't know DVD players. CD players, which were like Walkmans, like the CD Walkmans, or well, no, CDs still exist, so you probably are familiar with that. And MP3 players, which kind of don't exist anymore after phones kind of came around, but anyway, so anyway, they're basically across a large category of goods. My main takeaway is that people were buying these extended protection warranties, even though the frequency of repairs were pretty low. Okay. All right, I think I'll have to end it there. I'm sorry that I did run over my initial estimate of time, but I guess you guys already knew that when you looked at the bottom of the video timeline. But thank you guys for listening. I do hope that you try a different variety of courses at Waseda University. I think a lot of different faculty have a lot of different viewpoints that can give a much richer education. And so even though some of the topics I talked about today in behavioral economics are interesting, it's not only behavioral economics that can be interesting. Okay, So really do try out different fields and think about like, well, I'm really interested in creating new theory or testing new theory or find out what your interest is. Or if you're really not interested in economics itself, but more how you to apply it, there's also courses on that as well. So I really hope that you get a lot out of your time at Waseda University, and do feel free to contact me if you have any questions. Okay, thank you. Bye-bye.